There are two inequalities that we need to just write down in the list of theorems that we saw yesterday. We saw six theorems, and even the proof of almost all of them are there. Uh, Not so difficult, and you can prove it. Now, the seventh one is the inequality. What do we mean by an inequality? And tell me some inequality that you have seen till now.
We can say inequality in terms of size.
No, I need an equation.
Okay.
Which is going to be greater.
Like greater than
Yeah,
or less than 2.
Which one is going to be greater in this two?
the right hand side.
Right hand side will of course be greater than or equal to. So this inequality is called the Bull's inequality. And then the eighth one, if A1, A2 till An are n events. Defined on sigma, then the probability of intersection AI from I is running from 1 to n is equal to, oh sorry, is greater than or equal to summation P of I is running from 1 to n minus in bracket n minus 1. This is an important inequality. Just write it down. We won't solve examples on this, but you should know this. Uh, if you want to prove this, then you can do it using mathematical induction. Is anyone who knows mathematical induction? The proof by mathematical induction. Anyone who knows mathematical induction? There was a complete chapter in your 11th standard.
Sir, we need to take the terms like for in the starting we need to replace n with k, then k plus 1 like that, I guess.
You're half right. Manis?
Yes, sir.
Yes. Do you remember mathematical induction?
Because actually I didn't have the chapter, or my teachers left it or something.
No. Happen.
Sir, I think first the step is that we need to take n is equal to 1 and then we need to put the values in that
Hmm.
equation. And after
Hmm.
that, we need to, I think, replace n by k and then we get the terms k, then k plus 1 up to n terms. Means we need to assume that k will also be a part of that equation. That's what I feel.
Okay. Where is Sakshi?
Yes, sir.
Yes. I need mathematical induction. Khushi.
So, in starting, we prove for n is equal to 1, and
Exactly.
then we assume for that it is satisfied for n equal to k. Then we have to prove for k n is equal to k plus 1.
Exactly. Very good. So, how do we prove this is, I mean, the statement of mathematical induction says that if you have a statement P of n, okay, P of n is some statement where n is a natural number. So we need to check whether this statement is true or not. And I'm claiming that this statement is true for statement is true for all natural numbers. Okay, this is my statement P of n. So P of n can be anything like 1 plus 2 plus up to n. What is the summation of n integers? The summation of n integers is what is the sum of first n integers, Sahil? Hasnan, Harshit, no one knows
N
what is
into
this
n plus 1 by 2.
n into n plus 1 by 2. So this is my statement. Okay. So the statement says that the sum of first n integers is equal to n into n plus 1 by 2. And I need to prove this statement. I'm saying that this is true for all the natural numbers. So how do we prove it is by mathematical induction. Mathematical induction says that you prove the statement, prove P of n for n is equal to 1. Okay. So if I put n is equal to 1, then 1 is equal to 1 into 1 plus 1 by 2. So I will prove it. Yes, it holds for n is equal to 1. Then it says that assume that P of n is true for n is equal to k. Okay. For if for n is equal to 1 it is true, then I will assume that it is true for n is equal to k, and I will use this, and then I will prove P of n is true for n is equal to k plus 1. Okay. So this is the mathematical induction, and proof of this last inequality goes by the mathematical induction. Fine. Uh, as your computer students, you should always remember mathematical induction. I think you will come across this a lot of times till you have mathematics in your syllabus. Fine. Now that's all. I'll just recall the theorem. So we started with probability of A complement. The probability of A complement is 1 minus probability of A. Probability of a null set is equal to 0. For any element event A, the probability lies between 0 and 1. If A is a subset of B, then probability of A is less than or equal to probability of B. Then probability of A union B is probability of A plus probability of B minus probability of A intersection B. For probability of union of three events, for the probability of union of three events, A union, B union, C, we have probability of A plus probability of B plus probability of C minus probability of A intersection B minus probability of B intersection C minus probability of A intersection C, and plus probability of A intersection B intersection C. Then the Boole's inequality says that probability of A union B is always less than or equal to probability of A plus probability of B. And the last one, probability of intersection of AIs is always greater than or equal to summation probability of AI minus n minus 1. Note that this n is nothing but the number of events. So now we will solve some examples. If so, probability of A is equal to 0.6, probability of B is 0.5, probability of C is 0.3. Then compute probability of A complement, probability of A union B, probability of A complement intersection B, probability of A complement intersection B complement, and probability of A complement union B complement. The first one, probability of A complement 1 minus probability of A, which is 1 minus 0.6 is equal to 0.4. The second one, probability of A union B. Oh, sorry. I've written here C. Probability of A intersection B is this. So probability of A union B is probability of A plus probability of B minus probability of A intersection B. We put the values of this 0.6 plus 0.5 minus 0.3.
0.7. Sorry, 0.8.
0.8. Next one, probability of A complement intersection B.
P of B minus P of A intersection B.
P of
B minus P of A intersection B.
why so?
Because intersection of A complement with B gives us the elements only in B but not within.
Okay. So we have A, we have an event B. So if this is A, this is B. You can look at A complement. The A complement will be this part, the outside one. An intersection with B is just this one. Okay. So A
Sir,
complement, just a minute. A complement intersection B is this part. So this can be given as, so probability of A complement intersection B is equal to probability of B minus probability of A intersection B. So we put the values 0.5 minus 0.3, 0.2. Yes, Saurabh.
sir, I was saying that yesterday when we looked at the theorems, there was one theorem which you showed, which was P of B is equal to P of A plus P of A complement intersection B, and we need to find out that only. So we can also use that formula, right?
I don't remember any such theorem.
No, yesterday no, P of B is equal to, okay.
No, no, if it is there, please let me know.
No,
I
yesterday
don't.
during the fourth one, you taught if A is subset of B, then P of A is less than or equal to P of B.
And how can we use that here?
Means we need to find out a P of A intersection A complement intersection B. No? So P of B is equal to P of A plus P of A complement intersection B. That's, I'm not saying that this is wrong. I think that we also can we use. I'm just asking.
Uh, Probability of A complement intersection B, that will be probability of B minus probability of A in that case.
Yes, yes, that only.
Yes. Yes. Fine. The next one. Probability of A complement intersection B complement.
1 minus probability of A union B.
That is why. Why is it? Why is it? You are correct. Let me just tell you this. I just need the reason why you feel so. Was it you, Sakshi, or Khushi? Who was it? Okay, anyways. We can think of it in this manner. Say A complement intersection B complement. This is equal to, by De Morgan's law, A union B total complement. This is by De Morgan's law. So A union B complement will actually be given by 1 minus A union B, probability of A union B. So I'll just write it down in detail here. So A complement intersection B complement is equal to A union B total complement. This is by De Morgan's law. So probability of A complement intersection B complement will be equal to probability of A union B total complement. By our first theorem, this is equal to 1 minus probability of A union B, which is equal to 1 minus, what was A union B? 0.8. So the answer is 0.2. Let's look at the last one, which is A complement union B complement. So first, second, third, fourth, and the fifth one we need to find probability of A complement union B complement. Now
Probability of A intersection B whole complement.
there is probability of A intersection B whole complement, which is equal to 1 minus probability of A intersection B, which is equal to 1 minus A intersection B is 0.3. Next example. A and B are two events. A and B are two events defined on sample space sigma. Can the following statements be true? Justify. First one, P of A is equal to 0.8, P of B is equal to 0.7, third, probability of A intersection B is equal to 0.8. Oh, sorry. This has need not be true. These are all like this. And the second statement is probability of A is equal to 0.8. Probability of B is equal to 0.7, and probability of A intersection B is equal to 0.3. Yes. Is the first statement true or false?
So I guess it can be true only if A is a subset of B.
No. Whether it is true or false, don't give any condition because we are not supposed to give the condition. Whatever is written, it is true or it is false in general conditions. In generally, I mean, you are right that if B is a subset of A, then this is going to be true.
So,
What about in general?
so first statement is true.
First statement is
True.
why do you feel so?
So of course the probability of A union B is less than or equal to 1. I mean it's less than 1.
Hmm, okay. Any other opinion? Yashodhan?
Yes, sir.
Yes. What do you think? Is it true or false?
So I think it is true.
I think it is true. Harshit? Sakshi?
Yes, sir.
It is true or false?
Not sure about it.
Ajay?
Yes, sir.
True or false? The first statement.
So I think it's true.
Okay. Chris? Ishika?
Sir, it is true because according to the theorem 7, A union B should be less than equal to P of A plus P of B. So in this case, P of A plus P of B is 1.5 and P of A union B will be equal to 0.7. So P of 1.5 is greater than 0.7. So it is true.
Okay. Where's Khushi? Yes, Vedant?
Yes, sir.
Yes, Khushi, tell me, is it true or false?
Sir, I'm not sure, but I guess it is false.
Why do you feel so?
Sir, because since you told that in general form, so P of A is equal is same as P of A intersection B,
Yeah.
and it cannot be true.
Okay. Vedant, you have something?
Sir, same. So I was going to say the same.
Okay. So, what do we have here is the statement is false. The statement is false because we know that A intersection B is always the subset of B, right? So, by our theorem, probability of A intersection B has to be less than or equal to probability of B. But probability of B is given as 0.7 and probability of A intersection B is 0.8, is larger, right? This is not true. What about the second one?
It will be true, sir.
Why?
Sir, false.
Why
So
false?
second one is also false.
Second one is also false. Why, Chris?
So so P A intersection B is equal to P A into P B.
Probability of A intersection B is equal to probability of A into probability of B. Why? Vedant, why it is false?
Sir, because P of A union B is greater than 1.
Yes, exactly. Uh, so here what happens is probability of A union B by our formula is actually equal to probability of A plus probability of B minus probability of A intersection B. So this turns out to be 0.8 plus 0.7 minus 0.3. That turns out to be 1.2. This is greater than 1. Probability cannot be greater than 1, right? And that's why so false.
Sir means for in this case the statement was false. Sorry, the condition was false because we had to use this formula P of A union B, and by using it, the it came greater than one, right?
Yes. Now, next example. The probability that a contractor will get a plumbing contract. Yes, 0.4. And the probability that he will not get he will not get an electric contract. An electric contract is 0.7. If the probability of getting at least one contract, if the probability of getting at least one contract is 0.6. What is the probability that what is probability that he will get first one both the contracts, and second one exactly one contract. Yes, let's just define the event first of all. What is the event A?
Getting a plumbing contract.
Getting
0.2.
just a minute, getting a plumbing contract. And the event B is
Getting an electric contract.
getting electric contract. Getting a electric contract. So using this, we'll have probability of A as 0.4. Probability of B is
0.3.
0.3.
1 minus probability of B complement, which is not getting an electric contract. So 1 minus 0.7 turning out to be 0.3. Now, after this, it is given that if the probability of getting at least one contract, which is nothing but probability of getting at least one contract, which is probability of
A union B.
A union B, which is 0.6. What are the things to be found? First one to be found is 0 point probability of
A intersection
A
B.
intersection B.
the second one. So this type of example, if you are not getting, you can simply make a Venn diagram and then you can see what you need to find. This is the event A, this is the event B. So you'll pass in introductory statistics or you'll pass in discrete mathematics. You need to pass in exactly one of the subject, then what we should write here, what probability we need to find, probability of can I write A intersection B complement union B intersection A complement. So when I say A intersection B complement is just this part, right? When I say B intersection A complement, it is this part. So you can see that in both of them, the sample point is going to satisfy just one event, conditions for just one event. Okay, so that's why this is what we need to find. Fine. So probability of A intersection B is equal to probability of A plus probability of B minus probability of A intersection B. This is what we have. Put the values. So 0 0.0 is equal to 0.4 plus 0.3 minus probability of A intersection B. So probability of A intersection B is equal to 437.7 0.1. Now the second one. Yes, what this will be equal to? Recall the axiom. Yes, tell me.
Probability of A minus probability of A intersection B plus
Mm,
Probability of A intersection B dash plus probability of B intersection A dash.
yes, that will work. But again, there is a problem that how to find probability of A intersection B complement.
Sir, we can write it as probability of A union B minus probability of A intersection B.
Yeah, and the same thing for the other one. Okay, so that is a correct way. Another one also, let's just think of it. If we could get something from the Venn diagram. So this is A, this is B. What I need is this part, right? This and this. So we can see that it is actually A union B minus A intersection B, right? So this is actually the probability of A union B minus probability of A intersection B. There is any problem, please ask, or I'll consider that it is clear to you. So 0.6 minus 0.1. So the answer is 0.5. Clear? So we'll stop here. On the next lecture also we'll just solve the examples again, some more examples on this topic.